8.6 area between curves with more than two intersections. So let's look at this graph to see what they mean. Okay, so the functions f of x equals 3x to the third minus x squared minus 10x, and g of x equals negative x squared plus 2x create boundaries for multiple regions. This is the graph over here. Okay, g of x is quadratic, so it's got to be the parabola. I'm just going to label it so I can keep track. This is g. And then f of x is cubic, so this one must be f. Okay, they have more than two intersections. They meet here, here, and here. So I'm going to find the area between the curves, which is going to be this region plus this region. Okay, the first thing is I'm going to find the x values of the points of intersection and label them from smallest to largest as A, B, and C. Okay, now if I had a graphing calculator, I could just graph it and use that to calculate the points of intersection, but you don't always have a calculator, so let's go ahead and calculate it by hand. Okay, so I'm trying to see when they intersect, so I'm just trying to see when f of x equals g of x. So let's set them equal to each other and then do some algebra. Okay, this is a polynomial, so let's make it equal 0. I'm going to move everything to the left side. So I have 3x to the third. If I add x squared, it will cancel the x squared, and if I subtract 2x, I'm going to get negative 12x. Okay, so let's factor out 3x. Okay, so if I solve this, I set it equal to 0, and I get x equals 0, and if I set x squared minus 4 equal to 0, I get positive and negative 2. Okay, find the x values of the points of intersection. Done. Label them from smallest to largest as A, B, C. So A is the smallest, B is the next, C is the largest. And then if we're looking at the graph, the points we found are right here. At x equals negative 2, the curves intersect. At x equals 0, they intersect. And at x equals 2, they intersect. But we don't always have the graph. So then we have to figure it out on our own. Okay, why do we care about the points of intersection? So we can find the area of the shaded region. So in part B, we're going to set up the integrals to find the area of the shaded region. We're not going to solve it, but we're going to set it up. Okay, let's start with area equals. Let's start with the first region. Okay, that's going to be this piece right here. Okay, what's that integral? That integral is from A to B or from negative 2 to 0. Okay, from negative 2 to 0, the higher function is the f, the lower function is the g. So I'm going to do f minus g. Let's see, what is f? 3x to the third, x squared minus 10x minus negative x squared plus 2x with respect to x. Okay, now the next piece of the region is going to be this curve, and that's going from 0 to 2. Okay, for this piece of the curve, this is the higher curve, which is g. This is the lower curve, which is f. So I'm doing g minus f now. So negative x squared plus 2x is the higher function, and if I subtract f of okay, I know we're not going to solve it, but I am going to simplify it a little bit because if I was going to solve it, I would want it a little bit nicer. Let's see, 3x to the third, I'm going to keep it 3x to the third, negative x squared minus negative x squared is positive x squared, so they cancel, and negative 10x minus, that's negative 12x. Plus the area from 0 to 2. Negative 3x to the third minus x squared plus x squared cancel, and then I have 2x plus 10x plus 12x dx. Okay, and then I could solve this by hand pretty easily, assuming this is not a calculator question, because if it was a calculator question, I'd put the whole thing in the calculator. Okay, there is another way you can solve it, which is useful when you have a calculator, but not when you don't have a calculator. So you can keep it in mind, even though it's not the normal way we solve it. It's going to involve absolute value. Because normally when we calculate the area between the curves, we do the higher function minus the lower function. And the reason we do that is so we get a positive area. If I did it backwards and I did the lower function minus the upper function, I would get a negative area. And then I would get the difference of the areas, which I don't want. I want the total area that exists there. So another way you could do this is you could do the integral all the way from -2 to 2. And then I'm going to take the absolute value of the difference of the functions. Okay, now I don't want to have to take the integral of an absolute value in general, but if I had a calculator, my calculator could do it for me. This is going to make this a positive value, even though this is negative, it's going to flip it to positive. The thing you need to be careful of is you're doing the absolute value on the inside when you do the f of x minus g of x. Don't do the absolute value on the outside, because if you do the absolute value on the outside, you're subtracting them first, which would mean that this is a positive answer, this is a negative answer, and your answer is pretty close to 0, and then they're going to absolute that answer very close to 0, which is not what you want. You want this whole area plus this whole area, and you want to include the whole thing. So if you want to try it on your calculator, you do the absolute value of f of x minus g of x, and it's just a shortcut. Okay, let's look at another example. Okay, example 2, the figure below shows the graph of 2 minus 1/2 x squared, which is this one right here. Actually, I'm going to label it so I can keep referring to it. And the line y equals 1. So this line right here, that's y equals 1. For -2 to 2, closed interval, set up the integrals to find the sum of the areas of the shaded regions. So I want this area, and this area, and I want the total of those areas. Okay, I can see that the first integral is going to go from -2, and then it's going to go to this point here, which I can't read easily from my graph. Okay, now, if it was a calculator, I could absolutely graph it, find the decimal value, and then maybe store it and then use it for my integral. But you don't always have a calculator, so let's do this algebraically. Okay, so what am I trying? I'm trying to find this point right here. Okay, I'm going to see what's intersecting at that point. This is the y equals 1 line. And then this is the parabola 2 minus 1/2 x squared. So I want to see when the parabola is equal to the y equals 1 line. So I'm trying to see when 2 minus 1/2 x squared equals 1. Because I can see the y value there is 1. Let's go ahead and solve it. -1/2 x squared equals -1. X squared equals 2. I get x equals the positive and negative square root of 2, which means that this must be at negative square root of 2, which means this one must be the positive square root of 2, which makes sense because the square root of 2 is like 1.4 something, or I don't know, something like that. Okay, let's set it up for the area. Okay, let's see how many pieces. It looks like 3 pieces. Now the first piece goes from x equals -2 until x equals negative square root of 2. Okay, from here to here, the higher function is the 1. The lower function is the parabola, which is the 2 minus 1/2 x squared. Okay, when you plug it in, don't forget the parentheses. When you subtract, or you could distribute as you're going, that's fine with me as well. Okay, now let's go to the next piece. I'm going to go down because I'm out of room. Plus. Okay, the next piece is this piece here. This goes from x equals negative root 2 to x equals positive root 2. Okay, for this piece, the higher function is the parabola, which is the 2 minus 1/2 x squared. And then the lower function is the y equals 1 line, so I'm going to subtract 1. Okay, we need one more piece. This piece over here, this piece goes from x equals root 2 to x equals 2. For this piece on the right, the higher function is the y equals 1. The lower function is the parabola, which I'm going to subtract. So either distribute or put it in parentheses, and then when you solve it, you can figure it out. Okay, so I have all three pieces going from -2 to 2. And I could evaluate this by hand, or I could put it in my calculator to solve it.